Hello pre-calc class. Today I want to go over a quick review of what we did during the week with finding optimum values for design. And what we have here is on number 33, the volume of a box problem that we had during the week. And remember, we started out where we had a flat piece of paper, and in this case they're saying our paper is 12 by 12. So we're going to cut corners out of it, which are going to be square. And because we don't know the optimum size for this sheet of paper, we're going to just say that the squares are x units long. And we're going to want to figure out what value of x gives us the maximum volume, so that when we fold them up, they form a box of maximum volume. So what we're going to do is we're going to consider what these dimensions would be. And remember what happened in class, where the dotted line that I'm drawing represents the base of the box. After we remove the corners and we fold up the tabs. So what we have is the dimension here is going to be 12 minus 2x, because you have an x on one side and x on the other. And on this side, this dimension will be also 12 minus 2x. Now this happens because both sides of the paper are 12 by 12, and it's, instead of being a rectangle, it happens to be a square piece of paper that we start with. Our final volume, when we construct the box, is going to be x tall in terms of height. Its width is going to be 12 minus 2x, and its length will be 12 minus 2x. When we write up a volume equation, it's length times width times height, which is going to end up being the polynomial that is 12 minus 2x times 12 minus 2x times x. On tomorrow's quiz, you should be able to put the volume into the calculator and use the appropriate graphing window to find the maximum volume. So I'm just going to pause while I bring up the graphing calculator and enter the equation in, and then I'll continue the video. Okay, well, I'm back. I have the graphing calculator up and running, and I just want to show you that there's nothing plotted right now. All we have to do is, into y1, plug in the function 12 minus 2x times 12 minus 2x times x. And then when we graph it, if you notice, my graphing window is not showing me anything that I expect to see. I expect to see an area for, when I look between 0 and 6, I expect to see a plot that looks like that, and it's going to come back around, but I don't see that. I don't see the max, so I have to change my window. So if you look at the plot, I'm going to change my window settings, and this is something that tomorrow you're going to be required to do. I would start off by just thinking about my x-axis values. They have to be somewhere between 0 and 6, because there's no way that if x is greater than 6, then the box can't be created, because the paper won't be big enough. If you don't believe me, just try plugging 6 in for x, and you'll see that when you do 12 minus 2 times 6, you get 0 for a length. So let me try graphing that and see if I see anything better. And you see, as it plots, I see the end of the curve coming down towards 4 and 5. So I need some more height to this graph. So I'm going to go back into my window settings. Instead of thinking the volume is going to be 10, I'm going to try to look and see how 100 fits the volume. When I graph it, I see a bit more of the curve, but I need a little bit more room in the y-axis. So I'll go back to my window and I'll adjust that parameter one more time. And maybe if I make it 200, I should have enough so I can see the entire graph. There I see plenty of the curve, and I'm going to try to find the maximum value. So I'm going to use the function under the trace menu or calculate menu, and I'll use the maximum value function. It asks me for a left boundary, so I'll type in the value 1, hit enter, and you can see that it has the left bound covered. And now I'm going to type in something to the right of the peak, and that would probably be about 4. And if you look, it covers, it's all the way to the right of that peak, and I just have to guess anywhere in between. So I'll put in 3 as my guess. When I hit enter, it calculates the maximum value for this box. Should have the maximum x parameter, which would be for the height, says that as long as if x is equal to 2, then my y value will be equal to 128. And remember what the y value is indicating. It's indicating what the volume would be. So you should really answer this question and say that the maximum volume is 128 inches cubed. I'm just going to pause. I'm going to change the display so we can work on the other type of box that we discussed today. Now in this problem, we have a flat sheet of paper. And let's just give the dimensions, let's say the dimensions are 10 by 5 inches. Where this dimension here is 5 inches, and this dimension here is 10 inches. Now in class today we talked about taking this paper and folding it from being flat along some bend lines so that it would appear to look like a U-channel. Now remember that the box, the x length will be here when it's flat, and that x length will be the height when it stands up. And the remaining length will be whatever our overall length was, which our overall length we'll say is 5, minus 2x. So this dimension right here will be 5 minus 2x, as we did in class today. And now when we think about our box, we have x. This dimension here is 5 minus 2x, and this dimension right here is x. So, and our, let me just erase this, our width dimension is going to be 10. So our volume as a function of x for this problem is going to be 10 by 5 minus 2x times x. So now I'm just going to get the calculator back, and I'll have that function entered, and we'll analyze how to find its maximum volume. Well, now we have our new equation in. It's 10 times 5 minus 2x times x, and we're now trying to find its maximum volume. So let's just, again, we'll go to the graph. Now this is a graph that we had before with the same window, and as you can see that the volume is much smaller because it only takes up a certain portion of the graph. So I'm going to just try to change the window settings so that the y values aren't so tall, but you don't really have to do this. It just shows better as far as for trying to find the maximum. So I'm going to change the x value, x max, to about 3, and I'm going to change the y max to about 100. Now when I graph it, you see that we reach our peak, and I'm just going to use the same function as before. I'm going to calculate the max, and I'm going to put in, for my left boundary, I'm going to put in 1, and for my right boundary, I'm going to put in 3. And my guess, well, my guess will probably be 1.5, and it found the maximum to be 1.25 inches. So my length of height for this box will be 1.25 inches, and my volume, as the calculator shows me, is going to be 31.25 inches cubed. I hope this video has helped, and take a moment to look through this video and your notes and get ready for that quiz tomorrow. It should be a short quiz, and the things that we did in this video will be asked of you to do on your own tomorrow. But you will have access to the graphing calculator, and you will have access to use those functions to find the maximum. So good luck, and we'll see you tomorrow.